Hello everyone, welcome back to this third module that we have been looking at in this AI/ML workshop. In the first module, we looked at a broad introduction to what is machine learning, and we looked at points such as, you observe data, you hypothesize something from it, and then you learn, and then you generalize based on your learning. And in the second module, we started looking at unsupervised learning, and we looked at an algorithm called the k-means algorithm, which was used to cluster a bunch of data points. And then, we started thinking about when this algorithm might not work that well, are there other algorithms, and so on. Now we are moving to third module, where we will start looking at another very interesting aspect of machine learning. In fact, what you can think of as the core problem in machine learning, and this is what we are going to call as supervised learning, right? So as the name suggests, so the difference between unsupervised learning and supervised learning is that there is some amount of supervision involved in this part of the problem. We have already looked at several examples for supervised learning. For instance, if you can recollect, we looked at an example of classifying given an email as whether it is a spam email or not spam email. That was a supervised learning problem because you had a lot of emails, and some emails were given the label spam, some emails were given the label not spam, and then given a new email, our goal was to figure out if this new email belongs to the spam class or the non-spam class. Now the question is, okay, so this is the setup. Now how can we develop algorithms that can meaningfully produce good predictions or good classifications in the test time, right? So that is, for a new email that was not part of the training set, how can we do well on the test set? So email classification is one example. So that is something that we saw already. So example, email classification. When I say that, it's spam or not spam, sometimes called as ham, right? So that is the email classification problem. So now we are going to look at supervised learning via another problem, which is also an interesting supervised learning problem. This specific problem that we are going to look at is not the main focus, but the major ideas that come out of it can be applied to email classification also, to the problem that we will look at also, and I'll talk about a little bit of this as we go along. So what is the problem that we want to solve now? Okay, here is the setting. The problem that we want to solve now is given the loan history of customers, we want to predict if a new customer will pay back loan or not, right? So for example, imagine you are the manager of a bank, and this bank has been running successfully for, let's say, 25 years, which means that you have a lot of historical data of customers who have taken loans from this bank. Most customers, hopefully, if your bank is a good bank, most customers have paid this loan back, and some customers did not pay this loan back. Now as a bank, you want to make sure that if you're giving loan to a customer, they better pay it back, right? So because that is, you're giving loan, you're giving some money to a customer with the trust that that money will be used by that customer for whatever purposes, education loan, whatever loan, bike loan, whatever house loan, whatever it is, but then that customer is going to pay back the loan on time. Now the question is, how can you be sure, or how can you make sure that you are actually giving loans to customers who would in fact pay the loan back, right? So now, can machine learning help? That's the question that we are asking. And now if you want to pose this as a learning or a machine learning problem or an AI problem, so then you would pose it like the way we have done it here. Given the loan history of customers, predict if a new customer will pay back loan or not. And what do I mean by history, right? So history just means historical data. That is, your previous data in your bank of all the customers who took loan and who paid it back, who did not pay it back. And now we want to predict if a new customer will pay back loan or not. Now here is a question for all of you to pause and think. If this is the problem that you want to solve, now what would be the features that you would require as a bank manager which will help you make a good decision of whether a customer should be given loan or not. Now remember, these features are features that you would want your historical data to contain, right? So whatever features that you may have collected should be there in your database of the bank, and now you want to use these features and the labels, which are whether the particular customer paid the loan back or not, to make a decision for a new customer who enters the bank today. So question, so start thinking about this question: what are the features? What are the features for this problem? Right. So pause and think. I will give you what the answer is. I mean, there is no single correct answer, but roughly, I'm sure all of you would have gotten what might be useful features for this problem. Okay. So what are some interesting features? Let's look at that in a minute. So here is the thing. So here is another way of setting up this problem. Here is this new customer Hari who walks into the bank today, and you are the manager and you want to decide whether Hari should be given a loan or not. Of course, you will take Hari's information. You are going to ask Hari a bunch of questions, which means that you are going to collect features about Hari, and then you also have this past customer's history, and now you want to somehow combine these two and make a prediction whether Hari should be given the loan or not. That's the problem. Now, here are some ways to think about the features for this problem. If you had paused and thought about it a little bit, so maybe you would have arrived at similar features like this, right? So, some of the features that you would have in the bank are definitely the name of a customer, the age of a customer, the gender, education, salary, perhaps whether that customer is married or not, the location, right? So whether it's an urban location or a rural location, these are the features that you really have about a customer, right? So if you're a bank, there are some details about the customer that the customer fills when he or she registers with the bank, and these are some typical things that you might have about the customer. There might be many more features, but these are, I mean, this is like a toy problem that we are talking about. It is a real world problem, but the setting that we are focusing on is like a simplified setting. Maybe there are many more features that a typical bank would collect, but that's beyond the point. The point is to understand what are typical features that we would want to use. Of course, these are what are called as features. Now the label is whether that customer paid the loan back or not, right? So in this particular example, this is a very small simplified example. So let's say there are only 3 customers in the bank from with respect to historical data, John, Mary and Smith, and their ages are given, their gender, education, etc., and then finally we want we have a decision whether that person paid the loan back or not. And now here is a new customer, which is Hari in this case, who's 20 years old, male. He has a BS degree and earns, let's say, $16,000. He is not married. He is from an urban location, and the question is whether Hari will pay this loan back or not. Now, this is the question we need to answer, right? So this is a typical supervised learning problem. You have some features and labels which are given to you, and from that, now somehow you need to answer the label question for a new feature. That is, you want to make a decision for a new customer, who's Hari in this case. Now here is a good time for all of you to pause and think about how would you solve this problem, right? So for this particular table that you're seeing here, right? So you have details such as all the features for 3 customers, John, Mary and Smith, and then you want to answer the question whether Hari should get the loan or not. Now, what is your answer? Should Hari get the loan or not? Now, is it an yes or no? You have to answer that. Well, now you also have to tell why did you why did you say yes or why did you say no, right? So what was your logic behind saying Hari either should get a loan or should not get a loan? Now, this is the fundamental problem of machine learning, right? So we have some data and we have a new test data point. So this is what is typically called as trained data. All this is trained or historical, however we want to call it. The typical parlance is this is trained data or training data, and this is the test data. And now from training, we somehow have to learn to make predictions for the testing. Okay, so so now, of course, I really would encourage all of you to pause and think as to how you would solve this problem. Um, as we will see, there is no single way to solve this problem. There are multiple ways you can think about this problem, and what I am going to do is, in this module, just as an introductory level, give you few potential approaches to solve this problem. These are by no means exhaustive. People have come up with so many techniques, and if you take like a full-fledged machine learning AI course, or if you register for a full-fledged machine learning program, you would understand the nitty-gritties of all the algorithms that exist there for this particular problem. The problem is so interesting and so relevant that people have developed so many different algorithms, and there are good reasons why there are so many different algorithms. We won't get into that, but what we want to do as part of this workshop and this course is that give a high level overview of a couple of algorithms which are intuitive and interesting algorithms for this problem. Okay,